Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which I will show you how to find the area of a kite and also how to find the area of a trapezium. So let's start with kites. So a kite is another quadrilateral four-sided shape. Looks a bit like this. Another name for it is a diamond. So here adjacent sides are equal. So it's not a parallelogram. So we call these two lines, this one here and this one here, diagonals. Even though they don't look like they're going in a diagonal direction, that's what they're called. So the properties of kites are that the diagonals actually intersect at right angles and they bisect each other. So that means that this distance here and this distance here are the same as each other. The two ones in green are the same as each other. And this one here and this one here are the same. So the two distances in yellow are the same. So why I'm telling you this is I'm going to show you why the formula for the area of a kite is as it is. So note, I've sort of divided this into triangles. So let's just consider this thing here as one big triangle. So I'm going to give names to the diagonals. So let's let this long diagonal here be x. So x is this distance here. And let's say that the other diagonal is y. So from here to here is y. Now, because the diagonals were bisected, this length here will be half of the length of the diagonal, y on 2, and so will this. So let's now look again at this triangle here. So what is the area of the triangle? Well, I'm just going to draw it over here for simplicity to show you. So the area, we have a base of x, and the perpendicular height is y over 2. So the area of this triangle is half base times height. Of course, 2 times 2 just equals 4. We get 1xy, or just xy on 4. That is the area of the red triangle. But this triangle here has the same area. A kite is just two triangles of the same size stuck together. So the area of the whole kite will be 2 lots of the area of the triangle, like this. Okay? And lucky we did some algebra before, we can simplify this. 2 goes into itself once, goes into 4 twice. So the area of the kite is just xy over 2, where x and y are the lengths of the diagonals. So this whole thing was to illustrate why the formula for the area of a kite is as it is. If you didn't get it, that's okay. You can still get by and find the area of kites. I just want you to try and understand why things work, because then you're much more likely to remember that. Remembering lots of different formula can be hard, but if you know why the formula are as they are, then even if you forget the formula in the middle of a test, you'll still be able to figure out the answer. So let's look at a few examples. So remember, the area of a kite is just the two diagonals multiplied together and then divided by 2. So let's say I've got this kite or diamond here. These sides are equal, so that's how I know it's a kite. So I'm going to say that this length here is 12, and let's say this length here, the whole length is 6. So the area of this kite will just be 12 times 6, multiply the two diagonals together and divide by 2. It doesn't matter the order in which you multiply the diagonals, because 12 times 6 is the same as 6 times 12. So 12 times 6 divided by 2, I get 36. Now, if no units like centimeters or whatever are written, you just write units squared like that. So the area of that blue kite is 12 times 6 divided by 2, which is 36 units squared. So let's now find the area of this new shape here. So note that all the sides of this shape are equal. They're all equal to 8 meters. So you might be tempted to think, oh cool, this is a square, the area is 8 times 8. But no, this shape is not a square because it doesn't have all its angles equal to 90 degrees. This shape's a rhombus. So a rhombus is basically like a slanted square. A rhombus is actually a type of kite. It's a special type of kite where all 4 sides are equal. So because it's a type of kite, we're going to find the area exactly as we have done in all of the examples in this video. So the area of this kite, this rhombus, special type of kite, multiply together the two diagonals, and then divide by 2. And you get 65 meters squared. Easy as. Now let's look at trapeziums. So we now turn our attention to a trapezium. So the shape here in black is a trapezium. It's a 4-sided shape with 1 pair of parallel sides. So we need a few measurements to help us out. So we're going to call A and B the lengths of the 2 parallel sides. This length here is called H. Remember, H is always perpendicular height, never slant height. So how are we going to figure out the area of this odd shape? Well, we're going to look at rectangles, because rectangles are really easy to use. So if I draw a rectangle here, I can find its area pretty easily. Notice that that area of the green rectangle is a little less than the area of the trapezium. If I now draw a larger rectangle around the outside like this, this rectangle is a little bigger than the area of the trapezium. Turns out the area of the trapezium is going to be exactly halfway between the area of the green rectangle and the area of the red rectangle. So the area of the green rectangle is just A times H, length times width. The area of the red rectangle is length times width again, B times H. So we're going to find the area of the trapezium by finding the number that's halfway between the green area and the red area. So to find a number halfway between two others, you just add them up and divide by 2. Okay, so that is the area of a trapezium. You more commonly see it factorized, I'm glad you know what that is now, like this, because you can take H out as a common factor. So this here is the area of a trapezium. So H is the perpendicular height, and A and B are the lengths of the 2 parallel sides. It doesn't matter which one you call A and which you call B. So the way that you figure out the area of a trapezium, remember we do brackets first, add together the 2 parallel sides, times by the height, and then divide your answer by 2. Let's have a look at a couple of examples. So what would be the area of this trapezium in blue? Well, we just follow the formula. Perpendicular height divided by 2, add up the lengths of the 2 parallel sides. So 11 plus 15 is 26. Times it by 6, divided by 2, and you should get 78. Again, if no units are written, you just write units squared. So what would be the area of this trapezium in black? Well, it has 1 pair of parallel sides, so we know it's a trapezium, even though it looks a little different to the trapezium in the last 2 examples. But even though it looks a bit different, we're going to do it the same way. So 14 is the perpendicular height because this line here is perpendicular to the base because it's at right angles to the base. So same formula. Area equals perpendicular height divided by 2 times the sum of the 2 parallel sides. So we get 40 times 7 or 280 millimeters squared. Okay, how easy is that? Well, I hope you've enjoyed this video and learned something from it. This has been the luckiest maths teacher in the world. Have a wonderful day.